show this inequality is true, can we perhaps show the inside integrand that this is somehow bigger? We notice the bottom is the same. Can we compare cosine and sine from 0 to 1? 0 to half pi. That's the graph of sine. That's roughly the graph of cosine. All right, one increasing, the other is decreasing. Perhaps let's say 1 is somewhere here. All right, so we're comparing which one is bigger, right? But from 0 to their intersection, looks like cosine is bigger. That's fine. But from this point up to 1, sine somehow is bigger. So we cannot tell definitively which one is bigger. So that way it cannot work. But still we can make substitution to begin with and turn it into a more easy to analyze function. So first integral, second integral, first integral, x, I let it equal sine t, dt is now cosine t, dx is cosine t dt. Alright, change the boundaries. Alright, when x is equal to 0, t is equal to 0. When x is equal to 1, t is equal to half pi. Alright, cosine x is now cosine of sine t. Square root of 1 minus x squared. 1 minus sine squared t. dx is now cosine t dt. So this time, 0 to half pi. At the bottom is just cosine square, square root of cosine. Right, obviously positive, right? 0 to half pi, all positive. Cosine t cancel out. Cosine of sine t dt. Right. So this looks nicer than previous. So the second integral, likewise, similar. X this time, cosine t. So dx, negative sine t dt, a little different. So I2 is now, when x is equal to 0, t is equal to half pi this time. Because this time is cosine instead of sine. When x is equal to 1, t is equal to 0. Okay. So sine x becomes sine of cosine t. Square root of 1 minus x squared. 1 minus cosine squared. Negative sine t dt. Negative, right? Negative. So get rid of negative sign. Switch the boundaries. 0 to half pi. Right? Bottom becomes square root of sine square. Right? Sine, obviously positive. Sine cancel out. Sine of cosine t dt. Right? All we have to do is compare this integral and that integral. Is this one bigger? Right? Can we show the integrand? Is this integrand bigger than that integrand? Right? So here's my claim. This integrand is bigger than that integrand. Right? When t is in this 0 to half pi interval. So it all comes down to proving I1 is bigger than I2. In other words, all we have to show is this integrand is bigger in this interval. Right? We prove this claim. So from unit circle, we learned that here is the angle theta. Of course, theta is 0 to half pi. Sine theta is the length of this line segment divided by the radius. The radius is 1, just length of this line segment. Theta itself is this arc length divided by the radius. Again, is this arc length, which is obviously bigger than the length of this line segment. Right, so theta is in the 0 to half pi. So following this logic, this time theta is, I treat theta as cosine t. Since t is within this interval, how about cosine t? Cosine t is within 0 to 1, of course within 0 to half pi as well. No problem. So again, we say, okay, sine of cosine t is less than cosine t, right, in this range. Now, how can I translate this into this inequality? Sine cosine t less than this, but now it's less than cosine t, right? So next I show cosine t is less than this part. Right, why is that? Because cosine x decreasing from 0 to half pi. Right, so t is already bigger than sine t. Right? T bigger than sine t in this range. So we apply cosine, change the direction of the inequality, less than cosine of sine t. That's the meaning of decreasing function. Right? The bigger it is, the smaller the function value is. Right? So really, cosine t is less than cosine of sine t, in this interval. Yes. So we now really established, right, this inequality. Really, cosine sine t, really bigger than sine cosine. Right, so, like I said, so this time, same boundaries, right? Bigger integrand, same boundaries. Integral obviously bigger. Right, so integral obviously